Hello, everybody, and welcome to the CAE OneWorld 2021 Virtual Conference and Trade Show. Thank you for joining us for the panel on leveraging disruptive capabilities through digital immersion. We're transmitting live from our studios for this session. And I'm your host, Philippe Perey, Head of Technology for the Defense and Security Group, and I'd like to introduce our distinguished panel members. To my left, Mark St. Hilaire, CTO and Vice President of Technology and Innovation. To my right, Nick Giannis, Senior Technical Fellow. Welcome. Joe Armstrong, to my left once again, Vice President, Global Business Operations, Products and Solutions. And finally, to my right, Steve Bakery, VP of Operations at CAE USA. This panel will be structured across three segments. First, CAE strategy and digital immersion and the benefits it brings to our customers. Secondly, the technology innovation trends as disruptive enablers, how we're making this possible. And finally, applying digital immersion beyond the training market space. Let's start off by understanding a bit more about what digital immersion means for our customers and what sort of benefits. Nick?
Thanks, Phil. So first of all, digital immersion is really about helping our customers and end users make better decisions and learn faster. Digital immersion embraces new technologies and innovation. It talks about this concept of digital twin, a high fidelity recreation of the real world. It means about total immersion and the ability to interact with the system. So simulating different possible outcomes in a way to reinforce skills and behaviors. It's individualized, it's self-paced, and it creates repeatable learning outcomes. It's applied at the big picture organizational level or at a government level to help in decision making. And it can be applied across different sectors: civil aviation, defense and security, and healthcare.
Great, thanks for the summary, Nick. Joe, how is this digital strategy impacting the defense and security offering?
Yeah, great question, Phil. I think it's fascinating when you look at the genesis of our company, which all started, of course, building flight simulators and trying to create that, digital twin or analog of reality that we put in the hands of students and instructors to help train, students to become better pilots. When you think about where we are today, we're fast forwarding 70 years. We now have flight simulators, the high-end flight training devices, just as one core element of our overall digital immersion strategy. And so today, we really think about what we offer to the market as a full suite or a full continuum of training systems. Whether or not that's a training system that targets, learning a couple of small, very precise tasks, all the way up into very complex military operations with full mission simulators connected through a fully integrated network simulation and training environment. At the end of the day for us, the important thing is making sure that we have a suite and a compendium of tools, simulation and training devices, those digital twins that we can provide as alternatives, to help supplement full and complete training solutions. And at the end of the day, making sure that we provide that training solution for the best cost and ultimately with the objective of trying to improve safety. Again, that touches on civil defense, healthcare. I want to speak about one product in particular that I'm quite excited about, and that's the CAE Medallion MR E-Series visual system. Sounds like a big mouthful, but what it is, it's actually a point source training solution, very specifically targeted at fast jet fighter trainers, fighter lead-in trainers, and fighter jet training. And when you think about that digital twin concept and you go up the level of skills, if you can imagine you're in a high performance aircraft, everything happens incredibly quickly. When you put on mission systems onto that aircraft, in many cases that are operated by one pilot or a complement of two air crew, there's a lot of very precise flying that needs to happen and training that needs to happen. And so you can imagine if you look at some of the tasks that are associated with fighter jet training and operating fighter aircraft, you're talking about low-level flying. So you're close to the ground. You got to get, very, very high fidelity versions and representations of terrain. Air-to-air refueling, where you're dealing with like micron, millimeter level movements to get on target and saddle up behind a tanker aircraft and put your drone in there to try and get fuel, all the way into target identification. All of those things are really pushing the concept of saying, hey, in my digital twin, I've got to be able to provide near eye-limiting visual acuity, just as if we were sitting in a real aircraft, performing those real operations. You add on to that the fact that, you're in a fighter, you've got 360-degree coverage requirements. In other words, I've got to be able to look over my right shoulder to see something behind me. You want to be able to represent that in simulation. You have 3D cueing. If you look at modern fighter aircraft and some of the cueing systems that are on board those aircraft, those are the kinds of technologies that you want to embed in a training system. So for the Medallion MRE series, we're really taking advantage of the highest in fidelity with the best cost per performance, right? Ultimately to deliver, again, a fighter jet trainer that's aimed at improving pilot proficiency across the full spectrum of tasks that they have, and ultimately reducing incidents during training. And you can imagine when you start doing live training, obviously you want to reduce the kind of impacts that you could have by making pretty catastrophic errors if you don't have experience in a very high fidelity simulator.
Well, thanks, Joe. That really sounds like the ultimate with this Medallion E series in terms of digital immersion. Let's turn to Steve. Maybe you can give us a few examples of what we're doing in the U.S. in terms of digital immersion.
Sure, Phil. We have many exciting things going on in the U.S. With direct application of these technologies to help the U.S. warfighter achieve mission readiness. One project we're doing right now is for the Defense Innovation Unit, which is part of the DoD that is focused on bringing innovative capabilities to the U.S. warfighter and solve critical problems. So in this instance, the Air Force, the U.S. Air Force is the customer, and it's all about pilot training transformation. So as the name sounds, it's bringing a transformative methodology to Air Force pilots learning how to fly or do their mission. So this is originally focused on the T6, but eventually will go to other platforms as the technology is delivered and proven. It's a knowledge management system we call CAE Adaptive Learning System. And you can imagine a system where a student, a pilot like Joe was talking about, is performing a maneuver, part of their training to execute that maneuver properly and efficiently and safely. And this system will measure how they perform that maneuver and then compare it to a standard, which is a standard created to say how they should be doing that particular maneuver. Then we have an artificial intelligence system that is looking at how they perform that maneuver and giving a score based on their ability to do the maneuver and giving feedback to both the instructor and the pilot. So in the case of the instructor can either accept or reject this maneuver as needing follow-on training or follow-on learning. And as the instructor does that, the system gets smarter and smarter and learns more about how the students should be doing those maneuvers. In the case of the student, he receives feedback on how he performed and gets micro-learning recommendations on how to improve their performance. So any particular problem they had with that scenario, they can go get refresher training or look at more detailed training for that system. So this is really a system that will give tremendous benefits to the customer. Economies of scale in terms of cost and in terms of rapidity of learning and getting proficient. So this is very engaging too for the student. You can imagine being a student and getting all this feedback and being told what you got to do to get better. And so it's a really exciting project. It's using agile development. So we're developing it incrementally and showing the customer as we go our capabilities. And we're going to be delivering this project in 2021 timeframe. And a second application is something we call a CAE Tracks Academy and CAE Sprint Trainers. And there'll be some innovation demos as part of this conference that you can go check those out if you want to see more information. But in particular, we have a series of sprint chairs, which are individual training systems for students. They can be networked together so the students can train as a collective unit. And that's what we call mission readiness. So they can all learn their parts of the mission and get mission readiness. Also, you can do what we call delivery at the point of need. So as you can imagine a low footprint piece of hardware training solution that can be containerized and delivered to where the training is needed. So where the students are, they can train right there at the point of need. A third really exciting area is focused on the U.S. military's need or desire, I would say, to get an immersive, and Nick talked about it, a digital twin of the world. So a high fidelity digital twin of the world that is very immersive, that scales up to massive numbers of entities or participants in a scenario, and also allows hundreds of participants training in that scenario. This is all leveraging cloud technologies, cloud computing, gaming technologies, open standards, which we can all put together and achieve massive scalability and high fidelity of a digital twin of the world for the purposes of training or mission operations.
Yeah, thanks, Steve. That's interesting. This concept of digital twin. I mean, there's an incredible application that goes beyond the notion of a flight simulator or the E-Series. I guess what's making this all possible? Perhaps, Mark, you can talk about some of the trends and enablers that are making this achievable today.
Absolutely, Phil. I mean, it's not a secret. The last 10 years has been a very, very rich period of digital technology. I mean, from the early days of big data on the web browser, to the big pivot of smartphones, which are mini computers at the end point. They're all powered by a very capable network of communication. If you look at innovation at CAE, it often comes at the intersection of trends and sectors which don't appear as very related at the beginning there. We have, the best illustration of this is healthcare. Healthcare at CAE, training for healthcare started, and we carry over all our lessons learned and our capability from the aerospace into the medical domain there. Medicine and aviation intersecting there. We have a continuous process at CAE. We're continuously assessing technology trend and the impact of those technology trends on society. And let me illustrate what I mean by this equation or this process there. If you just look at last year, what we've been through in the pandemic, we've literally witnessed the explosion of remote working, remote learning, remote living. The technology that were behind those capabilities or those systems were there before the pandemic. What we really saw is an explosion of the consumption of those technology, which has taken them to a new level. CAE is essentially a high-tech company there, and 2 years ago in 2018, we committed $1 billion investment over the next 4 years in a project called Digital Intelligence. And the heart of that project essentially is to transform the training experience using digital technology for the people we serve, the pilots, the soldiers, the doctors, the nurses. Behind that transformation, as Joe and Steve and Nick has talked about, you could see the full scope of the digital technology from cloud computing, artificial intelligence, and I'm skipping dozens of them there. But let me talk about a very concrete example. How did it materialize? Take augmented reality, virtual reality, head-mounted display there. For the last 10 years, we've been monitoring those technology from the early, products that hit the market back in 2010. And if you look at those products back then, there were new medias, essentially designed with a very precise use case in mind. The use case was the gamers market. People wanted to provide a better experience to the gamer. Instead of looking at a flat screen, you would look into this new media and you would get a complete immersive experience there. When we look at that, it looked like a very compelling idea. Why don't we use those technology and translate them into a cockpit trainer? And as a concept, made a lot of sense. But, as my colleague pointed a bit earlier there, we've been buying every piece of equipment that came to the market. Some of the startups died along the way and bankrupt, never deliver. But there was something, which prevented those technology. The visual accuracy of most of those devices were clearly insufficient for the pilots to be able to read their screen. It's not until recently, over the last 2 years, that new products, new headsets, purposely designed for the professional market, came into availability. New device which came with the visual accuracy and the complete chain of technology to deliver that visual accuracy into your visual scene there. The moment we saw them, we say, okay, this is a turning point for us. And at that point, we decided to launch the CAE tracks that Joe has talked about. A complete virtual reality or augmented reality, depending on your choice, training solution which is easily deployable. A very good example. Joe?
Mark, if I can add, this whole concept of convergence, right, bringing technologies of various forms together to create a new solution. The whole is greater than the sum of its parts, is often a term we like to think about. Is actually the application of our new concepts on how to deploy rear crew training systems. And if you think about the complexity of modern aircraft, especially modern mission-enabled aircraft that have I mean, especially ASW platforms, they've got acoustic systems, they've got EO/YR systems, they have sonobuoys, deployable sonobuoys. They're taking in and integrating information from a full command and control environment. You can imagine that the crew on the back of the aircraft has a very, very daunting task, right? Not only are they responsible for managing all the individual systems, they're responsible for being aware, out the window of what's happening in their environment, especially in search and rescue type situations. And often they're actually operating other hard systems on the aircraft, like gunnery, door guns, and so on and so forth. So when we looked at the advance of helmet-mounted display technology into the next generation, which is mixed reality and augmented reality, it provided us a very unique opportunity to, again, converge all of those solutions into a much greater system that could be done independently. So if you can imagine that you're sitting in the back of, let's say, a Hilo, an ASW platform, and you've got the requirement to have your back end doors open, you've got your ramp down, you're one person sitting at a gunnery system, they have to look out the window. Well, if you put a fully immersive helmet-mounted display, obviously you're not going to see the fuselage, or you're only going to see a simulation of that fuselage. In this case, we can say we're actually building a full physical mock-up of a fuselage of an aircraft with all of the systems on board, all of the equipment on board. I can give you an augmented reality helmet that you use to not only see those live systems, but when you're looking outside the window of the aircraft or the hatch or the ramp, what you're seeing, instead of just a projector system on the backside, just like in the movies, you've got a blue screen, but you as the user will never see that. What you'll see is a completely synthetic world as you look outside the fuselage of that aircraft. I mean, the power of that is incredible, and I can tell you, having been put those helmets on and actually interacted with those training systems, I mean, it's just incredible. You truly feel like you're in the real aircraft and you're actually seeing the real world outside of you. And so this provides, obviously, the ability to train at a level we've never been able to train before for very significant elements: gunnery, search and rescue, confined area landings, hoist and hatch features for exercises, and everything from refueling to unslung loads. And again, you think about, why are we doing this? It's to increase training and optimize training. So now you have a platform that acts almost exactly like the real aircraft. You can see the external environment to it, but you're not restricted by doing a live training exercise where you're now impaired by weather. You may have aircraft and crew availability issues. Simply fly the aircraft. Now this can all be done in this mixed and fused reality type of simulation. And again, I'll go back to the term, the digital twin of the training environment in which you're operating.
Thanks, Joe. That's interesting. It's got the crossover, right, between the technologies our kids are using in the basement while they're playing their video games into a professional environment of delivering better training. So it's interesting to see that. One of the other terms that we spoke of just a bit earlier, I think Steve spoke about it a bit, the aspect of machine learning and data analytics. Mark, can you talk a little bit more about what that means and how it benefits the customer?
The omnipresent machine learning, artificial intelligence, certainly a dominant technology trend which is cutting across many, if not almost every sector today. If you look at the fundamental of our business, I mean, the fundamental is all about learning, education, the training experience there. That domain is extremely data rich. And on top of that, it's got some of the key elements of artificial intelligence that makes them very successul. It's got human subjectivity, human judgment into that learning process or learning journey. If you unpeel the learning experience, you look at the content, the media it's delivered with, the artifact which are left behind after the training experience. And if you pay attention to all of those elements there and you start instrumenting, all of those to give data during the consumption or during the journey, you collect a phenomenal amount of data during that learning journey. And when it becomes really interesting is, the human elements that you start to collect, the human assessment, the human performance, the human judgment on the overall ability to assess a student and proficiency or skill there. I mean, that key element allows you to close the machine learning loop and give extremely interesting results, into a big learning system, a modern digital learning system. I mean, we've been at the sharp edge of this transformation. We've instrumented our products, the flight simulator, the training material, the self-paced training have been instrumented to yield data. And about 2 years ago, we've introduced a product called CAE Rise, which enables, empowers the instructor with, virtual insights coming from a machine learning artificial intelligence algorithm to augment the instructor in his ability to assess and student in their ability to learn very precisely what's relevant and what's personalized to them.
It's very interesting, Mark. I mean, it's more than just searching on the web and getting bombarded for a week with very targeted ads. It's
totally.
harnessing that same technology and machine learning and AI, as it's called, and applying that to the benefits of training. Joe, maybe you want to talk to us a bit about some of the products where we're applying this very same capability.
Sure. So it's a natural evolution into the Trax Academy concept we have, which is very much about the philosophy of training and education and enabling systems and technology to support that philosophy. And if you think about it, we always break down as people, the way that we learn and train ourselves on any task. Doesn't matter if it's learning how to cook a recipe or it's learning how to fly an aircraft, through a couple of stages, right? And those stages first start off with learning. So you need to learn about the environment. You need to learn the facts. You need to start building the knowledge that you have on how a particular system operates. And that can be down at the very, very bottom level of the food chain. And simple things like, how do I open that menu? And how do I press that button? And what happens when I press that button? Into practicing that knowledge. So you have to expand outside of just learning, whether or not you're receiving that education from a classroom instructor or a highly digital enabled courseware, you need to then start applying that knowledge. And you do that typically through a practice phase, whereby, you want to have hands-on experience with a training system or the real system to start enabling you to try out that knowledge and expertise that you've gained. Now, in the Trax Academy, how we start building this concept is quite linked to the various kinds of technology that we've been discussing here. When you're in the first learn phase, I mean, you have a whole suite of learning tools. You have digitally immersed courseware. You have the opportunity to use VR headsets and helmet-mounted displays to help you navigate through concepts as you're learning. When you step into practice, the sprint trainer comes into play, where you now have a relatively low fidelity in the context of a full mission simulator or full flight simulator, but a very affordable training tool that allows you to have force feedback, which is now on the market and readily available, high fidelity simulation and visual systems, which is certainly available to us today, fully integrated courseware, and virtual coaching and assessment that is starting to generate data as to your performance as a student as you are practicing that maneuver or practicing that task. Now, the big advantage of something like RISE and the use of artificial intelligence is you can start to match the progression of a student through that practice phase to their actual capability. In other words, if I'm better at visual tasks than Phil, you are in a mechanical task, well, the whole training system will start to adapt the delivery of those practice sessions to try and compensate or bolster us in the areas that we need, additional support and additional work. Now, as you get through that practice phase, so now you've started conglomerating all of the knowledge and information and skills you've generated as you've gone through the first phases of learning, now it's time to perform those tasks. In other words, you need to now progress to a full flight training device, a full flight simulator, or even a live aircraft to fully integrate all of that knowledge, experience that you've gained through the learn and practice phases into operating a full system at its full level of capability. Now, in the context of flight training devices and live aircraft, typically you also have an instructor. Sometimes you can have a virtual instructor, sometimes you can have a human instructor. However, CAE RISE, as Mark talked about, is now in the position to start gaining very large data sets of information about how you are interacting with that aircraft in this example, and what are the things that you're doing that are potentially not driving you to optimally performing, in that particular platform. And again, the big advantage now is because so many of our systems are digitized, whether or not it's in a live aircraft or whether or not it's in the simulator, we can collect all of that data. And again, that data is then tailored to that individual's progress through the training system. And so you can think about this as you step back from it and think holistically about an overall training system or a Trax Academy type approach. it provides you the opportunity to continuously improve your training delivery. It allows you to optimize your training system to meet the individual requirements of students, where your end goal is, I need to train as many people as I can to a high degree of effectiveness as fastly and in as tailored a way as I can possibly get. And so when you think about the life cycle cost of an overall training program or a training system, this really allows you to tailor it in the most optimal way that's going to be the most cost efficient for you as a customer to be able to produce a very comprehensive and successful training outcome at the end of the day.
That's really interesting, Joe, because you're really getting the convergence of the worlds, right? You have the gaming technology, the helmet-mounted displays, the application of AI, the bringing that together into an entire training continuum is pretty interesting. It's got to be efficient in terms of delivering pilots faster. We've heard a bit about cloud computing, and where does that fit in all this picture, Mark?
Cloud computing, Phil, certainly a compelling area of interest for us. I mean, it's not a secret. Cloud computing has displaced on-site, on-premise computer servers, mainly for spreadsheets, business processes, documents, email, the stuff that the business is running into. Cloud computing is more efficient, cyber secure, it's scalable, and it's been a massive movement from the on-site premise server to the cloud computing capability to do those business processes. If you look at our business, the flight simulator, the massive software machine, with almost millions of lines of code essentially. But they have the additional challenge that the ones and zeros in the software are driving real systems, driving real actuator, moving a 30,000-pound piece of equipment, we're driving forces and queuing in the cockpit, there's lights. So there's a real-world interface there. Nevertheless, the challenge that we face when we write those millions of codes of software is the same challenge which are typically faced by the large gaming company, the large software teams, where you get engineers, software engineers, which are distributed over several time zones or several geography, working in their own software modules there, but software module fits into a bigger set of software that executes the purpose at the end there. And to work efficiently, I mean, the world of software in those environments has moved to what's called a Devops, essentially. It's a cloud service, essentially, that lets everybody work in a development environment, compile, test the code, and push the code into push its own piece of code, fully tested into an operational environment for the service to be delivered. I mean, it's a very efficient and has accelerated the software. That process has accelerated the software in this industry tremendously. Now, if you look at ourselves, what did we do? How can we benefit from this? I mean, we're facing the additional challenge of the software interfacing to the hardware, the real sharp end of the training device there. I mean, for us, I mean, the transition to the cloud came with the standardization of the interface, the hardware interface, the simulator. It's the price that you have to pay to benefit from the efficiency of having a DevOps environment, which is, unique and capable of handling all those pieces of software. But you get a known interface at the other end that you can deploy your software in operating environment. In all the trade-offs that we made, the cost to standardize the interface versus the benefits of the DevOps environment and the migration to the DevOps environment has been extremely positive for us. I mean, we've been migrating from development into the cloud to testing in the cloud to compiling, integrating, deploying the software from the cloud to the endpoint device, and now we're looking at runtime from the cloud. And all along, those trade-offs has been positive, provided you standardize the interface of the receiving end.
Yep. Great. Thanks for painting that picture, Mark. I guess cloud computing is all of a sudden a little bit less nebulous than it was a moment ago.
And the DevOps environment as well.
The DevOps environment, yeah. Maybe turning perhaps to Nick, maybe you can tell us a bit where we're applying this capability, say, in the healthcare field?
So healthcare is an area that has dramatically benefited from cloud computing, Phil. So for us, we've created kind of a new generation of training solutions in healthcare based on cloud computing. For one reason, and I'm going to use a term from the U.S. military, the idea of a point of need, delivering training to wherever the trainee is, whether they're at their workplace, at their home, or whether they're in a schoolhouse. The ability to deliver that training where they are is crucial. So cloud computing, because as Mark said, it removes all the servers and all the hardware and software and puts it remotely, delivering it through the high-speed networks that exist today. It makes that entirely possible. So an example of that at CAE is the CAE SimStat product, which is allows training of anesthesiologists to do their continuing education through this whole remote learning and assessment process. So this particular product has different training modules, and it was developed along with the American Society of Anesthesiologists. So we're currently expanding that model, distributing it to virtual classrooms so that you can have that classroom experience as well. So students can interact and collaborate in the same environment, right? Kind of like we are doing with CAE OneWorld today, and regardless of where they are physically. And because of the essentially limitless power of the cloud, we're not limited in terms of the virtual, the fidelity of the virtual environment that's there.
Yep.
But also very importantly is the level of simulation and fidelity for this kind of training. So we, in this particular case, we're simulating the actual physiology. We took simulation models that we had already in our mannequin products and moved them to the cloud so that the anesthesiologists are experiencing the same level of fidelity from the physiological aspects of it. And the feedback that they get, it's not just visual feedback with all the squigglies that you and I may not know, but obviously are extremely meaningful. These are real, right? And they respond to what the anesthesiologists do in terms of interventions. So overall, I think that capability really takes advantage of the cloud and makes this new kind of training possible.
That's interesting. So it's not just a remote classroom; it's bringing that advanced simulation model and applying it, right on the computer screen at home, so those anesthesiologists can practice or have that ongoing education programs and get the right credit. So an interesting application for cloud computing. I guess from an operations standpoint, where does cloud computing fit in all of this? I mean, is there benefits there for our defense and security customers? Joe, maybe you could chime in on that one.
Yeah, I'd be happy to. I think Nick and Mark really gave a good indication of the whole concept of point of need solutions, right? And if you think about it internally as running a business and running engineering development, et cetera, you have a highly distributed workforce. I mean, we've all, learned what it's like to operate in that kind of environment. And you can't afford to necessarily set up giant server farms in everybody's house simply to allow them to do development. So the whole concept is saying, look, I got to be able to provide systems and capabilities that allow highly distributed teams of people to be able to access data and their development environments and automated testing systems and so on to make that distributed workforce act as seamlessly as they can, as if they were actually sitting beside each other in a war room or a development room of some kind. So, certainly the advent of cloud computing has a lot of impacts internally on our own heavy infrastructure, on our IT requirements going forward, and then how do we support development in general for our people. When you think about AI, and AI is always a fascinating topic for me. I look at AI as having major macro outcomes in one of two areas. One is they allow us to predict the future, right, through generating trend data and generating analytics that show us where something is going, whether or not it's a development effort or whether or not it's a real system operating in the environment. But they also allow you to reflect on the past and diagnose things that have already happened, right? And so one's predictive, one is more of a diagnostic tool. And when we think about operations, certainly the operations of a company like ours, our critical number one mission is to deliver to our customers the best solution that we can on time, on budget, on quality. So as we are starting to digitize all of the information and systems that we use internally to operate and perform our business, that has obviously great positive benefit because it allows us to access that data in close to real time, which is always the holy grail of data access. It allows us to provide predictive tools and analytical tools like some of the other gentlemen have talked about to look at that data and answer questions for us. What happened on that program that we ran into a challenge and Can we diagnose why early on so we can apply that to all future programs? What is it if we see a risk in the future on development or working with a particular customer in terms of access to data or information or defining a requirement? How do we predict what that impact will be so that we can give our customers options, to navigate alongside of us in partnership the most effective way and the ability for us to deliver, highly customer-focused solutions that really at the end of the day meet their need.
That's it's a lot clearer now, Joe, to understand that there's some tremendous benefit that's brought forward by cloud computing and AI. But in this connected world where we're all at home and we're dialing in or developing software, I guess one big question that people have on their minds is, what about cybersecurity? What is the challenges that we face, and what solutions are we developing that are addressing cybersecurity? Maybe Steve, you could talk a bit about how we're applying that in the U.S.
Yeah, sure, Phil. I'll amplify on what Joe and Mark and Nick have said. And in the U.S., we're creating what you would call a high fidelity digital twin of the world. And you can imagine let's say the U.S. military has to do a humanitarian mission in some urban environment anywhere in the world. And so we want to create this environment to very high fidelity, replicating all the buildings in that environment, all the roads, all the bridges, and also have what we call pattern of life in that, in that training environment where you see the people that would be normally milling around doing what they're doing, and cars and et cetera. So you can get the idea of a high fidelity environment. This is all leveraging cloud computing. So you have massive amount of participants in the scenario. You could have hundreds of students learning what to do in their particular part of the scenario. But getting back to your question on cyber, I want to talk about how we bring this all together. So CAE is a global system integrator. We have engineers all around the world, and what we've created, and Mark mentioned this, he talked about DevOps. We have in the military, we talk about DevSecOps, where the security is important, cyber is important, and we embed that into the process. So what we mean by that is we create a development environment where we can have developers all around the world, basically from CAE and from our partners, because we work with many partners on many programs, and bring the best of breed technology together for a particular customer in the U.S. military. And this DevSecOps environment, it covers the whole environment, the development life cycle, if you want to call it. Processing. So development of the actual application, embedded quality assurance checks so that we can make sure we're delivering a quality product, cybersecurity checks embedded right into the process, and then eventually deployment and integration of all those capabilities together into one seamless application which provides this high fidelity digital twin of the world. This allows us to have an environment where we have a culture of collaboration, like Joe talked about. We're pulling people together, it doesn't matter where they are, and creating an application that works for our customers. This DevSecOps process includes what we call continuous integration. So we work in an agile framework where we deliver capability every 2 weeks, and we can review it with the customer, that we can get their feedback, we can tune it, we can continuously improve what we're doing. We can do continuous delivery. So as we want to updates and things like that can be delivered in a continuous manner, and also deployed. So several of my colleagues mentioned point of need. A very important thing to the military customer is training at the point of need. And so this continuous deployment of our applications allows us to deploy that application to where it's needed in the world so that we can get effective training. So this is all the philosophy behind integrating cyber into our whole process to ensure that our applications are cyber secure and meaningful for our customers.
That's very good, Steve. I mean, you think about it, this whole cloud computing is bringing together the scalability, the robustness, the point of need, as you guys described it, and it's certainly going to bring benefits in the training realm. I guess the question is, looking at the more broader mission operations support, as we orient to that market, what are the applications of some of these capabilities? Mark?
I mean, an open question you threw at me there, Phil. I mean, you look at digital immersion, you look at synthetic environment, you look at the boundary between the training world, the synthetic world, and the real operating world just blurring away there. We talked about digital twins. You know, when I talk about digital twin, and I always, you know, to people who are just introduced to this and say, okay, what is a digital twin? And I refer to, you know, the Lyft or Uber application on your smartphone. You open that application and you will see a map, and you will see little moving taxis and in a map of where you are there. And the little moving taxi essentially are a digital twin of the real metal taxi, which is out there with a real driver who's been on a shift, who's available. And if you look at that synthetic environment, you know, which connects those things, it achieves, you know, a sort of a real purpose, connecting a very efficient system between you got a need and there are people ready to offer a service.
Where the taxi is a few minutes away.
The synthetic environment calculation will find the most close by driver and will vector it on a map and will take you to the destination. I mean, it's quite of a, you know, chain of technology all deployed together, and that's a very day-to-day good illustration what a digital twin is. You know, very, very good. Now, to me, we're looking here, you know, we're just at the beginning of one of the most exciting technology trend, you know, which is going to unroll onto us over the next, I would say, 10 years. You know, those large synthetic environments, which we're going to connect several things together between the operating world, the synthetic world, the real data feed. We're going to be able to run them at faster than real time. We're going to be able to deploy the agents, robots to get intelligence into this. This is one of the hottest technology trends which is happening now. And along that trend there, you got the UK government, you know, which in my book, I believe is a visionary in that trend there. For the last 2 years, we've been executing a contract called the Single Synthetic Environment with the UK government, where we have built, leveraging a game engine, a large synthetic environment which has got real data feed from all the government branches of the UK government. You know, so we're not only talking about defense application, but we're talking about, you know, government operation, logistics, border, healthcare system, utilities, satellite information, populations. We collected all those layers, and then you can just imagine, the possibilities of, achieving the same type of benefit as a Uber application, that efficiency or intelligence being able to be achieved once you connect that. You can imagine, connecting in a time of pandemic the data from the healthcare system with, the border controls, the border control information, or from the traffic pattern information. You can imagine connecting electricity utility with social media, so you can pinpoint immediately electricity shortage faster than any other system there. The possibility are enormous into this there. It's very, very exciting. All of that there is happening in front of us, and we are positioned to take, CAE to right into this trend.
So these operations rooms aren't just in the movies, right? So that you can really bring this capability into a real world.
Phil, you and I are old enough to remember old movie, science fiction movie, which were, unscrolling the future faster than real time to be able to take the right action before it happens. Well, some of this was a vision back then, is a capability along those lines is being developed now.
Right. And Mark's right, these are visionary capabilities. And in the UK, with the single synthetic environment, we're really leveraging multiple aspects. So there's the data aspect, both real-time or historic data that's going to be used as part of the simulation. There's the use of AI, right, both to predict the future, as Joe was saying, or maybe to even understand what happened in the past. There's high-fidelity modeling, and not just modeling of traditional areas like defense and security, but also social media aspects, right? The human aspects of the world in which we live in, and the interaction between that and defense and security. That's critical for enabling, I think, a new kind of generation of understanding. And of course, there's the connectivity, the ability to leverage that wherever you might be, whatever your job is. And really the intent is, as kind of mentioned at the beginning, is for better decision making, for better planning, for better communication, for coordination, for training as well, and finally for testing. So one of the main applications for the single synthetic environment for the UK government is course of action analysis, being able to run multiple scenarios, initialize them with the current knowledge state, and then run many hundreds, thousands potentially of scenarios to look at the ones that are most likely to occur, and then build plans around those scenarios. And really what they're looking for is second and third order effects, because the individual first order effects, we've been there, we've done that.
Yeah.
But when you start combining the way the population behaves with the way,
problem, right?
yes, it becomes a lot more complex, right? And it scales up dramatically very quickly, and that's where things like cloud computing are going to get us there.
You know, it's kind of interesting because you think back, modeling and simulation, we think of real time, but in this case, you're describing this faster than real time simulation. So you're really playing out all those outcomes in a simulated world and coming back with that recommendation of your odds here are greater if you go this way instead of going that way. So it's got an interesting application of modeling and simulation. Steve, do you want to talk to us a bit about what we're doing in the U.S. From your perspective?
Yeah, sure, Phil. Like Nick was saying, we're applying these technologies for the U.S. military in what we call the mission operations space. So the whole purpose is to improve decision making from commanders and warfighters wherever they are. So basically, what we're doing is creating what we call a common operating picture. And we're doing this for a particular customer in the U.S. military. So what does that mean? That means that they can get situational awareness on the scenario that they're working on or the event that they're dealing with, and understand what is happening, understand where all the different moving parts are of the event, and what all the individual participants in the event are doing or need to do. And so the commanders can make better decisions. So we leverage these technologies like cloud computing to get the scalability that Nick was talking about. Containers as a kind of a cloud, component. MOSA architecture, so modular open system architecture. Mark talked about open interfaces, and this is a system that allows you to plug in new capabilities as new technologies. Yep. And for this common operating picture, we're reading the system is smart, the interfaces are smart, then they can read data, what we call structured data. So I talked about before, like an urban environment where there's a building or terrain or water or a bridge or whatever that is. And unstructured data, so Intel feeds or Twitter feeds, other kinds of data that are not as structured, and the system interprets them and fuses all this data together with sensors. So like a live sensor that might be showing some video of a particular location, or other types of sensors, and fusing that into one data picture. And that picture gets presented to the commander to allow them to see what is happening. And also gets presented to the participant or the warfighter that's in a particular area. And what's important about that is we also layer AI on top of that, artificial intelligence. So the artificial intelligence is looking at the scenario and making what we call action recommendations, decision support to the commanders. And the commanders can decide whether to do what the system's recommending or not. And as that happens over time, the system gets smarter and smarter, and is able to make better recommendations. So this is a very exciting thing for our warfighters and for our commanders. And the other important point is deliver to the point of need. Nick mentioned that. So cloud computing allows us to deliver those recommendations to the point of need, whether it be for the commanders or for the people working in that scenario. There's other applications of this in the U.S. that are just starting to happen. We think this is directly applicable to another major initiative for the U.S. Air Force. They call it ABMS, a battle management system, basically, that allows for what they call joint all-domain command and control. So basically, it's what I just described, but providing situational awareness that covers all domains, so space, cyber, land, water, and aviation. So all spaces fused together into a common operating picture that can give situational awareness to our warfighters.
This is really interesting, Steve. This common operating picture, it sounds like it's sort of the culmination of a whole bunch of different disruptive technologies coming together in this overarching digital immersion strategy and sort of the culture of CAE's approach to this innovation. Nick, maybe you want to summarize some of these disruptive capabilities overall.
Sure, Phil. I think there's a huge appetite for disruptive capabilities. I think that's clear. We're all seeing in kind of our day-to-day lives the pace at which commercial technology is evolving. and our customers basically want to ride that bandwagon, right? See how they can leverage it for their own challenges. And CAE is obviously looking to the same kinds of technologies, and we have a wealth of expertise in the past. We've been involved in cloud computing for well over a decade. The same thing with virtual reality. Back to the 70s when we created our own virtual reality headset for many millions of dollars, and thankfully that price has gone down. But we also have, I think, the appetite to explore, right?
Yep.
Willing to take risks, and certainly the commercial capabilities that exist, the ability to quickly try something, prototype it, see if it's ready. Mark mentioned this for the VR headsets, right? We were buying and testing every single VR headset we could get our hands on to see if it could actually meet the requirements of the customer. And the requirements wasn't about playing a game. The requirements was for doing real training, right?
Better training.
We're leveraging DevOps and DevSecOps to be a lot more agile and adaptive. We recently completed a project internally where we harnessed literally the entire worldwide force of CAE and its partners to turn it into a 24/7 operation to deliver faster than I think we ever have before. But at the same time, we're focusing on customer needs. Right? It's not technology for technology's sake. It's really technology that matters as far as our customers are concerned. And of course, I think like a lot of technologists, myself for sure, is we're aware of the trends, but it's picking on the trends that really can have an impact. And one way of doing that, at least internally, we've organized ourselves around something we call the digital accelerator to create these digital experiences.
Okay, well, great. Listen, thank you very much. I've been told that we're out of time, so this has been a fascinating discussion. I'd like to thank you all, for all the panelists, for their insights today, and thank you all for being here. So I now invite you to join our live Q&A session, where the CAE panelists will take your questions. To ask a question, please select the Ask Question button to the upper right on your screen, type your question into the box, and click Submit. Thank you very much.
Thank you.
So we have already some questions up from our audience. How does CAE ensure they are focused on and considering the right technology? Maybe, Mark, do you want to talk a bit to that?
Yeah, a very open question there, and this is part of the heart of the process. Every year on a continuous basis, you see an onslaught of technology. And then you have to make a decision, on a continuous, every company has got a calendar, and we're no different. We got a strategic planning calendar, and then we're looking, okay, what's happening? Is this technology ripe for what market? How can it come into our market? So this is a continuous process. I think, there's not a single answer to the question. There's several things you need to do. First, be aware of what's happening, then, go out there. I got a large team of people that are deployed to all technology events and forums there. But you need to, after that, make the very rough decision. Okay, what are you going to inboard? What product you're going to focus? What experiment? What prototype? Which customer are you going to, approach with this? So it's a continuous process, not a single answer to this.
A single answer to that one.
Yeah.
I mean, it's interesting. Another question we have here is about how do we adopt the technology? How do we apply it and make sure that it's ready for marketing our products? And I think Nick, you ended by mentioning the digital accelerator. So maybe Joe, you can talk a bit about how we're applying the digital accelerator, how we're using that as if you will, an incubator of capabilities for new innovations to go to market.
Yeah, it's a great question. I'll follow on from what Mark was suggesting. When we think about digital accelerator or supercharging our ability to innovate, which is really at the end of the day what this is all about, it has to encompass a bit of a cultural transformation internally, but also a transformation in the way that we interact with our customers and ultimately our market. CAE has a pretty broad reach, right? Not just on the commercial, civil, business jet aviation side, but also on the military side, on the healthcare side. And we participate in a lot of general high-tech forums and thought leadership type of activities. And so when you innovate, right, the concept of innovation has to cover those two streams. It has to cover what we see as opportunities to help our customers achieve their success faster, better, cheaper than they did before. And then our ability as a company to integrate new technologies that we form as part of our solutions and then we put on offer to our customers. So when you think about the difference between what I would say is like the far-reaching, forward-reaching innovation, I mean, that's where we want to be on the bleeding edge, on the very cusp of new things that are coming out to market. Mark talked very clearly about how we do that, right? We have people, we're implementing research programs. We have our fingers in a lot of futuristic pies, so to speak. But when it comes to really implementing something, right, you need to typically generate enough critical mass on an idea and a maturity of that idea that you are preparing it for, technical readiness, if we're speaking technology, to actually incorporate itself into either prototype designs or ultimately fieldable designs to our customers. There's actually very good, rigorous ways to do that, right, where you're monitoring the progress of all of the ancillary things that have to get put in place for you to evolve technology. That then obviously has to be incorporated in terms of our baseline. Now, one of the things that's happening, and I think it's a wonderful place to be in the market today, with our customers today, is the intimacy that we have with our customers means that in many cases, we're able to do joint development. So not just, having a bright engineering idea internally to our company and then trying to sell that idea, but really meeting that, the point of need or requirement that comes out of our customer space that we develop together, right? And we say, let's explore this idea together. Let's explore this new piece of technology. Let's do this in partnership. And it gets you to the position where you now have highly relevant capabilities that can be brand new, right? Brand new to us, brand new to our customers, but we didn't do it in isolation. And I think that message is absolutely critical.
Yeah, that's like
that point.
It's a bit the shift, from this waterfall development to this agile cycle where you're working with the customer through the demonstration of those capabilities in a way that you get feedback very quickly, so make sure the things you're developing are right. We have an interesting question here on CAE's position and integration of eye tracking within the context of development and assessment of situation awareness. And maybe it sort of raises the broader question of biometrics. Nick, maybe you want to talk about some of the experimentation we're doing, some of the work we're doing there with regards to getting that as an additional set of data and how we can use that to assess how students are performing.
So I'm going to hand this over to Mark, who's more intimately aware of our experimentation in this area.
This is an active project, deep. Eye tracking technology has been around us for, I think, 6 years. And the challenge is to, what do you do with the information? I can give you a gaze point dynamically, in various situations. And when you look at it with a bunch of experts, it looks pretty interesting, and you can draw a conclusion and say, it would be wiser if this and this and this. But how do you translate this into a day-to-day scenario where somebody's going to say, I can consume that technology, is going to augment my ability to either assess a student, assess his awareness of a situation. That is the challenge, and it's something you cannot do alone. You need, we have an R&D project which is done in conjunction with a leading airline, a world leading airline, and a bunch of university who are expert into the cognitive load of the brain. So, very appropriate question. I think, we're going to see over the next year or so, from eye tracking to, what's the real use case in real life
that people training, right?
Yeah, how does in our case training? How does what do you do with the information that can be consumed by Mr. Everybody, every instructor?
Okay.
Yeah.
Very good. Actually, I'll segue on to our next question here. With the deployment of CAE Rise, do you see the change in the role of the instructor and how they deliver training? And maybe Nick or Steve, you want to talk a bit about that, and how this is an assistant, not a replacement of, or perhaps as we've called it, sort of the smart aid to the instructor. Steve?
Well, I can talk to that. It applies both in the civil and defense domains, even healthcare. We talked about AI, to measure student performance and how they're doing and giving and scoring them and stuff like that. But this instructor is still a fundamental piece of the equation and a very important part of the whole thing. And really what happens is the instructor is the one that's using their professional judgment to look at the data that's being presented on how that student performed in whatever maneuver they're doing. And really, the system will recommend something to the instructor, but it's up to the instructor to say, yeah, I agree with that, or no, I don't. and that's based on, really professional years of experience, and that is hard to simulate in a computer. So really, the idea is that the artificial intelligence, every time the instructor makes a decision about, yeah, I like that recommendation, or no, I don't, the system learns, and maybe next time that scenario happens, recommends a better outcome for the instructor. So the instructors are still key, absolutely key to the whole training equation. Really, the system wouldn't be effective without them.
Sort of supercharging the instructor, not replacing him or her, right? Maybe one last question here: as we look at choosing the right technology, how do we make sure that we're on the right track? And some recent programs, perhaps one last question for Nick, as we look at using some of the gaming technologies, some of the helmet mounted displays, how do we know that we're on the right path? How do we use the validation process to make sure we're going the right direction?
And it's a great question, Phil, and I think it's a challenge with any technology, right? And I think the question talks about any pitfalls to technology. I mean, my view is if you develop what you don't want to do is develop a tunnel vision, right? You're so enamored with some bit of technology that you keep following it, even when you realize that, maybe it's great, but it's not ready yet, or maybe it's not the right technology for what you want to achieve.
Right. Okay.
So you have to be ready to admit that, okay, maybe the timing's not right. I'll park it on the shelf and move on to something else and see if maybe later I can bring it back again because the use case makes more sense, or my customer has a new requirement or something that makes it much more relevant than it used to be.
Sort of the fail fast, fail often, right? Make sure that you're out there trying it, and if it doesn't work, move on, right?
Yeah, and I think we've all been there where you get so excited about some technology, and Mark's example of the eye tracking it's great technologically. A lot of people think it could add a lot of value, but the challenge is, what is the value, and how do I present it? What does it translate into directly? That's really the challenge.
Thank you so much, Nick. Fantastic. And I'd like to thank you all for joining us here at CAE OneWorld 2021. For more information about CAE and what we offer, I invite you to visit our Innovation Hub to view our product demonstrations and to visit the Knowledge Hub for the on-demand presentations from the CAE Amphitheater. We also invite you to contact your CAE representative or visit the Base Camp reception area to connect with CAE personnel. For more information about the CAE and what we offer, visit our Innovation Hub, and look forward to networking you within the networking lounge to connect with people that can talk about some of the capabilities we have. So thank you ever so much. Thank you, panelists, and this has been a great discussion. Thank you.
Thank you, Phil.
Yeah, thanks very much.